everyone, how are you all? I hope you all are doing good, you all are fit and fine, you all are healthy and safe. And your studies are going in a smooth manner. You are very consistent with your studies because, as you know, consistency is the key to clear any exam. I am your educator Nidhi Dua and I warmly welcomes you to our channel GurMantra Shiksha Ka Granth. Guys, this is our GATE 2021 exam syllabus. This is our section 1, atomic structure and periodicity. We have completed atomic structure and we have started the next topic of section 1, that is periodicity. In periodicity topic, we have read about periodic table and we have started periodic properties. In periodic properties, we have learned about Z effective, atomic radius, and in this particular lecture I am going to explain you about ionization enthalpy. So let's get started without any further delay. So basically, ionization enthalpy or ionization energy is the minimum amount of energy which is used to remove the outermost shell electron in the gaseous isolated atom. Removal of that particular electron from the outermost shell of a neutral atom is always an endothermic reaction. As you know, endothermic reactions are those reactions in which energy is involved, energy is absorbed, but removal of an electron from any species, which means any ion, it could be positive ion or it could be negative ion. In that particular case, the reaction could be exothermic or endothermic. The basic difference between exothermic and endothermic reaction is exothermic reaction do not absorb heat, it liberates heat, while endothermic reaction absorbs heat. There are many factors which affects the ionization enthalpy. Number one factor is your Z effective. As you know, we have learned about Z effective. Z effective is directly proportional to ionization enthalpy, or we can say ionization enthalpy is directly proportional to Z effective, which means as you increase the value of Z effective, the value of ionization enthalpy will gradually increases. Second point is ionization enthalpy is inversely proportional to 1 upon size, or ionization enthalpy is inversely proportional to size, which means, as you know, Z effective is inversely proportional to size. That's why ionization energy is inversely proportional to size. Means as you increase the value of size, ionization enthalpy will decreases. Third most important point is electronic configuration. Stable half-filled and completely filled electronic configurations has the maximum ionization enthalpy because the outermost electron is tightly bounded in that particular condition. Next is charge. Ionization energy is directly proportional to positive charge while it is inversely proportional to negative charge. As you know, Z effective is also proportional to positive charge and inversely proportional to negative charge, and therefore ionization energy is directly proportional to Z effective. Here comes an example by which we can understand the concept of pseudo-noble gas configuration or noble gas configuration. Pseudo-noble gas configuration means half-filled condition and noble gas configuration means fulfilled condition. So basically what you have to do is you have to write the electronic configuration and search and find the noble gas or fulfilled condition, and when you get the noble gas or half-filled condition or fulfilled condition, you can easily get the order of ionization enthalpy. Next is variation in periodic table. In a particular group, when you move from top to bottom, size increases. As you know, value of Z decreases, Z effective decreases, size increases and IE decreases because Z effective is directly proportional to ionization energy. Here comes some important orders which you have to remember. As you know, this is inorganic chemistry and this is mandatory to revise inorganic chemistry on daily basis. So number one example is the group 1 element: lithium, sodium, potassium, rubidium, cesium and francium. As you move along the group lithium to cesium, the value of ionization energy will decreases because size is increasing. But when you move from cesium to francium, the value of IE will increase, which means maximum value of ionization enthalpy is for francium. Next, in case of halogens, IE decreases as we move along the group. For secondary elements, from beryllium to strontium, value of IE decreases, but in case of barium, value of Z effective increases, therefore IE value also increases. In group 13, on the basis of data, this is the order which you have to learn, which you have to remember. In group 14, PB has the maximum IE. For group 4 to 12, in case of transition element, in case of D block element, 5D series has maximum value of IE, while 4D series has the minimum value of IE. In period, as you move along the period, value of Z effective increases, and you know Z effective value is directly proportional to ionization enthalpy, therefore ionization enthalpy will also increases. But some variation can occur in this series due to the stable configurations. The stability or order for the configuration is noble gas configuration, then pseudo noble gas configuration, then incomplete octet, which means noble gas configuration means full filled configuration, then pseudo noble gas configuration means half filled configuration, and incomplete, you know it very well. This is very important to note that isotopes has the almost same ionization potential or ionization enthalpy. Ionization potential is also known as ionization enthalpy or ionization energy. In transition series, in D block elements, the ionization potential changes irregularly. Here comes an example in which you will get the order of IE1 for the following. So this series is given to us. This is along the period. So basically what you have to do is, first of all, you should know the atomic number of the different elements. So you should have a clear-cut idea about the periodic table. So when you write the number of electrons in the outermost shell, you write the electronic configuration of that particular atom. You will get to know about the pseudo noble gas configuration, full filled condition, or about the incomplete configuration. So basically, when you have written the electronic configuration, you get to know that Be has full filled configuration, that is 2s2. Nitrogen has pseudo noble gas configuration or half filled configuration, that is 2s2 2p3. Neon has the full filled configuration, that is 2s2 2p6. And as you have seen in the previous slide, that full filled condition or noble gas configuration has the maximum amount of ionization enthalpy, then the pseudo gas configuration, and after that all the incomplete configuration. So as you know, along the period as we move, the value of IE should increases. So therefore when we move along the period from Li to Be, value of IE increases, and also the value of Be is more than lithium because this has the fulfilled configuration. If we talk about Be and B, the value of Be should be more than B because Be has fulfilled condition as compared to B because its outermost shell has 2p1 electron, which means it has incomplete octet. Next we have B and carbon. In B and C, C should have the higher amount of ionization enthalpy because, as you know, we are moving along the period. We are moving along left to right. Therefore, carbon should have the maximum amount of ionization enthalpy as compared to B. If we talk about carbon and nitrogen, nitrogen should have the maximum amount of ionization enthalpy because this has the pseudo-noble gas configuration, that is 2p3. Next, in case of nitrogen and oxygen, nitrogen should have the highest amount of ionization enthalpy due to its noble gas configuration. In case of oxygen and fluorine, fluorine should have the higher amount of ionization enthalpy because we are moving along the period. But in case of neon, the maximum amount of energy can be seen because due to of noble gas configuration due to its fulfilled condition. So here comes the final outcome of this result, as you can see here. Okay, now there is a question, that is, write down the order of IE1 for the following. You have given a series and you have to tell the order of ionization enthalpy. Here I would suggest to please pause your video and do this question quickly. Okay guys, let's see the solution. So basically, first of all, you have to write the series, then the electronic configuration of that particular element. As you know, the atomic number of sodium is 11, therefore we have written the outermost shell electronic configuration as 3s1 because for ionization enthalpy, for calculating the ionization enthalpy, you should know about the outermost electron because in ionization enthalpy is the minimum amount of energy which is required to remove an electron from its outermost shell. So the outermost configuration of sodium is 3s1, magnesium is 3s2, aluminium has 3s2 3p1 and so on to the argon. So basically, as you know, pseudo-noble gas configuration and noble gas configuration should have the higher amount of ionization enthalpy. So we have highlighted those elements which have fulfilled condition or half-filled condition. So basically magnesium has fulfilled condition, that is 3s2. Phosphorus has pseudo-noble gas configuration or half-filled configuration, that is 3p3. Argon has the fulfilled or noble gas configuration, that is 3p6. So when we have written the order of IE, this comes out to be the order of IE1, ionization enthalpy 1. So basically, you know, when you move along the period, the value of IE should increases. Therefore, and also in case of magnesium, so noble gas configuration can be seen. Therefore, in between sodium and magnesium, the value of IE should be greater in case of magnesium. If we talk about magnesium and aluminium, the value of ionization enthalpy should be higher in magnesium due to the fulfilled condition. In case of aluminium and silicon, silicon should have the higher amount of ionization enthalpy as you are moving along the period. But in case of phosphorus and silicon, phosphorus should have the higher amount of energy due to half-filled condition and you are moving along the period. And in case of phosphorus and sulfur, the value of ionization should be greater in phosphorus due to half-filled configuration. In case of sulfur and chlorine, the value of ionization enthalpy should be higher in chlorine, and in case of chlorine and argon, argon should have the higher amount of energy due to its fulfilled condition. Therefore, argon has the maximum amount of IE and sodium has the minimum amount of IE. I hope you guys are now cleared about the concept of ionization enthalpy. The basic things which you need to remember is, first of all, you should know about the atomic number of that particular atom. You should know about the number of electrons present in particular atom. You should have a clear cut idea about the electronic configuration of that particular atom. Okay, so now comes a application of an ionization enthalpy. So basically, if you know about the ionization energy, ionization enthalpy, you can simply tell the relationship between metallic and non-metallic character. As you can see here, ionization enthalpy is directly proportional to non-metallic character and inversely proportional to metallic character. Which means if you increases the ionization enthalpy, non-metallic character will increases, and if you decreases the ionization enthalpy, metallic character will increases. Let's take an example to understand this formula or understand this concept. We have given a carbon family, which as you know, this is a group. We are talking about a group. And also, you know, as we move along the group from top to bottom, size increases, value of Z effective decreases, and if the value of Z effective decreases, IE should decreases. And according to this formula, if IE is decreases, ionization enthalpy is decreasing, then the order of the metallic character should increases and non-metallic character should decreases. Next point is reactivity of metal. If you want to know about the reactivity, you should know about the ionization enthalpy, because reactivity and ionization enthalpy follows a inverse relationship. If you increases the value of ionization enthalpy, the value of reactivity, the reactivity of metal should decreases. As you can see here in this diagram, in this picture, if you move along the period, ionization enthalpy increases as the value of Z effective increases and size decreases, IE increases, and therefore metallic character decreases. And as you move along the group, IE decreases, metallic character increases, and reactivity increases, because you know reactivity is inversely proportional to ionization enthalpy, and ionization enthalpy is directly proportional to non-metallic character and inversely proportional to metallic characters. Next is reducing strength. Reducing strength is also inversely proportional to ionization enthalpy. For example, if you talk about the first A group element, from top to bottom, size increases, therefore ionization enthalpy decreases, and if ionization enthalpy decreases, reducing strength increases. But in this particular series, if you talk about the aqueous phase, the reducing strength do not depends of ionization enthalpy, it depends on the standard reduction potential of that particular element. So therefore the order becomes this, and lithium has the maximum ionization enthalpy or maximum reducing strength due to the small size. Next we have a practice question. The question says, arrange the following in decreasing order of ionization enthalpy. You have to tell the decreasing order of ionization enthalpy. You have given these orders, these options. Here I would suggest to please pause your video and solve it quickly. Okay guys, so let's see the solution. So guys, in this particular question, you have given the outermost electronic configuration, that is in option A that is 2p4, in option B that is 3p5, in option C this is 6s2, and option D this is 2p3. So first of all, you should know about the pseudo-noble gas configuration or noble gas configuration. As you can see here, 6s2 is noble gas configuration and 2p3 is noble gas configuration. And here you should also know that you have to see the periodic trend, which means along the period ionization enthalpy should increases and in group ionization enthalpy should decreases because due to the Z effective value. So the order comes out to be this. The value of D is much greater than the value of A, then B, and then C. As you can see here, 2p3 is the half filled condition, pseudo-noble gas configuration, but still the ionization enthalpy for D is maximum because 2p3 He2s2 2p3 has the least number of atomic number, while xenon 6s2 has the maximum atomic number, and this is talking about along the group. That's why I hope guys, you all guys are now cleared about the concept of ionization enthalpy. In case if you are new here in our YouTube channel GurMantra Shiksha Ka Granth, please do like, share and subscribe. You can also join our Telegram channel named GurMantra. And for further queries, please mail us on tanejanehaofficial and @gmail.com, and you can also contact us. Thank you so much guys. I hope you all are now cleared about the ionization enthalpy concept.